Arithmetic Series, Section 8.3. What is a series? A series is a sum of the terms in a sequence. So now, not only have we been able to find what the terms were and what place in the sequence they were, but now we're going to add them up. Now there are a couple different types we could have. The finite case and the infinite case. So I know you hate the summation notation, but you got to get used to it, all right? The sum as I goes from 1 to 10. Starts with 1, right? First term, second term, third term, fourth term, and stops with the 10th term. Being a fixed value on the top gives me the idea that it has a stopping point. That's how I know it's finite. This looks an awful lot like an explicit formula for an arithmetic sequence. So if you had written out some of the terms, you would see that you had a 3 and an 8 and a 13 all the way up to the last term, which is 48. I find that by plugging in a 10. So the infinite series starts with 3, then 8, then 13, and continues on up forever and ever and ever and ever and ever. And if you think about that, you can never find a sum. The infinite arithmetic series never has a sum, ever. So keep that in mind. I want to tell you about a story about little Carl Gauss. Little Carl, back in the late 1700s, was in the first grade. This is a true story, by the way. I'm not just making this up. He got in trouble with his teacher, and his teacher thought that his punishment should be that he needed to add the integers from 1 to 100, thinking that this was going to take the kid a long time. You know, he's going to have to skip recess and all that good stuff. Well, little Carl Gauss was a genius. Much better than I. And he saw a pattern. And he said, okay, well, what's 1 plus 100? Well, that's 101. What's 2 plus 99? That's 101. That's 3 plus 98. That's 101. And he said, well, how many pairs are there? How many pairs are there from 1 to 100? There's 50. So he multiplied these two numbers in his head, and the kid wrote down 5,050 on the blackboard. That's the only thing he wrote down, and he was correct. So what the teacher thought would take him a while did not take him a while at all, because he figured out a formula which we are going to use. And from here on out, I'm going to refer to it as Little Carl. Now, Little Carl's formula said you needed to take the first term plus the last term. So this is first term. And this is the last term. Add them together. And then multiply by n over 2. That's the pairs. That's the number of pairs. Now, you can modify Little Carl's formula if by chance you do not know the last term. If you don't know the last term, well, there's a little bit of substitution. We actually substituted in for a sub n. We substituted in the explicit formula, right? Because we know that a sub n is equal to a sub 1 plus d times n minus 1. So we actually did that substitution, and this is the equation we came up with. So if by chance you do not know the last term, make sure you use the second formula. So I skipped example 1, although I could do it quickly. Example 1 said, what's the sum as I goes from 1 to 6 of 2n minus 1? Well, keep in mind that this is all one unit. So it's an arithmetic sequence of numbers. Therefore, we can use Little Carl on this, and when we get done, we'll subtract 1. So Little Carl says, we'll find the first term, plug in a 1. 2 times 1 is 2. Plug in a 6, find the last term. 6 times 2 is 12. There are 6 numbers, right? 1 through 6 are the number of the terms, so there are 6 numbers. And so the sum of those 6 terms, 3 times 14, or 42. And then don't forget to subtract the 1 at the end. So this particular value is 41. So that was example 1. Example 2 says you've got $4,000 that you borrowed. In this textbook, they said it was a loan for college, or college expenses, I should say. You've got 100 months to pay it back, and the payments look like this: $60, $59.80, all the way down to $40.20. That's your last payment. How much did he repay? Well, we know the first payment, we know the last payment, and we know the number of payments, right? So 60 plus $40.20 is $100.20 times 50. So 50 times $100.20. So he's going to repay $5,010, even though he only borrowed $4,000. At 100 months, you're almost talking almost 2 years to repay that. Excuse me. What is wrong with me? 100 months? I was thinking weeks. This kid's got over 8 years to pay this thing back. Wow. What's wrong with me? Okay, so in example 3, they say that this particular marathon runner is going to run 7,500 meters the first day, 8,000 meters the second day, 8,500 meters the third day. How many meters does the person run total in 30 days? Well, this is a situation where I don't know the last term. So I'm going to use the modified little Carl's formula, right? N over 2 times the first term plus the constant difference times n minus 1. Okay? So we've got 30 days. We do know the first term, right? That's 7,500. The constant difference between the terms, we know that's 500, right? Because every time it's going up by 500. And we know that there are 30 terms, and so the n also goes in that place. So the sum of the 30 terms, and we'll reach over for the handy-dandy machine. Two times 7,500 plus 500 times 29, because that's 30 minus 1. That value times 30 divided by 2 is 15. 442,500 meters. Okay, so that's your. So my last example is a 10-foot log that needs to be cut into 5 pieces. Each piece is 8 inches longer than the previous piece. We are not taking into consideration the thickness of the chainsaw blade or the chain itself. Okay, obviously we would have to do that since it takes out about 1/4 of an inch, maybe a little bit more than that, but each time you make a cut. This sounds like a situation where we do not know the last term. All right, I shouldn't say, we don't have the first and the last term, so we can't solve for both of them. So I think we're going to solve using the modified little Carl formula, because that's the one. 8 inches is obviously the distance between each piece, so that's the common difference between the terms. And we have, and I know it looks like we don't have, there's 2 things we don't have here, the sum and then also the first term, but really we have the sum. If it's a 10-foot log, that's 120 inches. And since our constant difference is in inches, I'm going to use 120 instead of 10 feet. So we have 5 over 2, 2a sub 1 plus 8 times 4. Okay, I want to get rid of that 5 halves, so I'm going to multiply by 2/5 on both sides. And so 120 times 2/5, oops, that's the wrong number, 2/5, 48. So we have, oops, I don't need that parenthesis anymore. 2a sub 1 plus 32. Okay, so subtract the 32, and the first piece should be 8 inches long. Obviously, then my pieces would be 8 inches more than that, 8 inches more than that, 8 inches more than that, 8 inches more than that. Those should be my pieces, and just for fun, let's see, make sure 8 plus 16 plus 24 plus 32 plus 40. That is 120 inches, so we do have the correct values for those, the lengths of those pieces of that 10-foot log. So, arithmetic series, a couple different formulas you can use. Sometimes you're using them one direction, sometimes another, but definitely pretty useful. I know that as I look at homework, I know that some of you are going to wonder about the difference in question 4a. You're going to wonder about the difference between I going from 1 to 5 of 2n plus 1 with parentheses, and part B, I going from 1 to 5 of 2n plus 1 without parentheses. Keep in mind that this part right here is together, and you're going to add 1 at the very end, whereas in this one right here, you're going to use that whole thing. So if you want to find the first term, you plug 1 in here. If you want to find the last term, you're going to plug a 5 in there. Well, that's the same type of thing here to find first term, last term. You're going to use little Carl's formula on both of them. It's just that this one gets added 1 each time, and this one only gets added 1 at the very end. So, and we'll talk more in class.